heaven, West Virginia, Blue Ridge Mountains, Shenandoah River. Life is old here, older than the trees, younger than the mountains, growing like a breeze. Take me home, country road, to the place I belong. West Virginia, mountain mama, take me home, country road. Hello everybody, welcome to this week's edition of Video Notes for Mr. Flugum's AP Chemistry class. That's right folks, we're talking AP Chemistry. And so we're going to be talking just about some basics about solutions, which is our next unit. So we'll look at types of solutions, concentration, and things that affect solubility. So why do some things dissolve and some things not? So let's go ahead and get started. Okay, to start out with, we've just got some terminology here, some basic things about solutions. So we'll talk about this, right? Suspension, or a mechanical mixture, really we'll refer to it as a suspension. We've got a solution, and then the two parts that make up a solution, right? The solvent, which is the substance that is more plentiful, and the solute, which is the substance that is less plentiful. So to kind of give you an example, as you're writing this stuff down, the solvent many times is water, right? And the solute might be something like this, some salt, right, that we're dissolving in that water. So if you need to pause right now so you can write down this information, go ahead and do that. We'll continue on after that. Okay, just two more kind of solutions terminology words for us, right? Some vocab. We've got saturated. So we can saturate a solution, right? That's where we take the solvent, right, and we put so much stuff in it that it can't hold anymore, right? It's like you just keep dumping more and more and more salt in until suddenly the salt can't dissolve anymore. That is a saturated solution, right? It's holding the maximum amount and we can't increase its concentration. And the other word is this, and we'll see this in our notes today, miscible, right? So miscible means this, that you can mix two things that are miscible are soluble in all proportions. So they never become saturated. It doesn't matter if we go 10% of one and 90% of the other, or we flip those proportions around. Miscible things are always soluble in one another. Alright, so we're very quickly here going to talk about different types of solutions. So one of those would be liquid-liquid solutions. For example, when we have some type of alcohol and water together. And what happens is this, right, is we have strong H bonds. So alcohols have this OH group here, right? This is the methanol, has that OH group, which gives us a hydrogen bond. And we have a very small nonpolar tail. That's really key, all right? These two substances, because of the strong H bonds that form, are miscible, right? That means that they are soluble in all proportions and we can never saturate the solution. Now we also have liquid-liquid types of solutions that are not miscible, right? So in this case, we have hexanol, right, which is a much larger alcohol. You can see it has this large nonpolar chain on it. Now, it has the hydrogen bond up here, so some or a very small amount of hexanol is soluble in water. However, it will become saturated because we have this nonpolar chain right here, right? That nonpolar chain won't bond with the polar water molecules, making the solubility of hexanol in water somewhat limited. Okay, now we have a liquid-liquid solution that is slightly different. In this case, water is not the solvent, right? In this case, let's just say this. We're mixing hexane and hexanol. And if you notice, they have these nice, long, non-polar areas, right? Okay, and that means this. As they mix together, so London dispersion forces can attract them to each other. So in this case, hexane and hexanol are miscible. because they have these long non-polar sections, okay, that can link together. All right. All right, here's just real quickly another type of solution. It's a solid liquid solution, right? So this is where we dissolve something solid in a liquid solute, right? So for example, when we dissolve ionic compounds such as salts, right? That would be an example of this. Also polar solids like glucose, okay? Glucose, because it's a dipole and it also has many H bonds on it, dissolves very well in water, okay? However, we can't take non-polar solids. In this case, they're talking about mothballs. That's like a chemical that chases moths away, right? It's a non-polar organic compound, okay? They need to dissolve in non-polar solvents, right? So again, the lesson comes through, right? If we have charges, right, they will dissolve in charged things like water. However, if we have things that are non-polar, they will only dissolve in things that are non-polar. All right, folks, so another example would be this, gas-liquid solutions. So carbonated drinks would be an example of that. Although what we get in that case is we get this equilibrium equation here, right, where the water mixes with the CO2 and forms carbonic acid, right? And then that reaction can reverse as the gas comes out of the solution. We also find this, oxygen gas and other gases dissolve in water in small proportions, right? So those would be examples of gas-liquid solutions. We can also have gas-gas solutions. For example, air is a gas-gas solution, right, where we have many different components that make up the air, okay? And if you notice here, they are always infinitely soluble in one another, right? It doesn't matter what proportions they are, gases will mix. All right, so here's where we get a little funky with our solutions. We can have gas-solid solutions, right? An example of that would be these hydrogen, this diagram here that represents hydrogen molecules that can, because they're so small, can hide in these spaces between larger atoms such as in iron or palladium. So that would be a gas-solid solution. So here's another one, solid-solid solutions, right? These are formed by melting things and then mixing them together and then solidifying it. For example, steel, right, is what's called an interstitial alloy, right? That's where we have very small carbon atoms come in and occupy some of the spaces between the larger iron atoms, all right? And that's called an interstitial alloy, right, because they are filling the spaces in between and they're much smaller, right? All right, another type of solid-solid solution is this. It's a substitutional alloy. So this is where we take a metal and replace it with another one when we mix it, right? Therefore, we have zinc mixed in with the copper here. That changes some of the properties of the metal and also gives it a different appearance, right? But in this case, since we are substituting atoms that are somewhat of the same size, it's called a substitutional alloy. All right, so let's talk real quickly, factors affecting solubility. So what affects the solubility of a substance in another? One is this, structure, okay? And keep this in mind, we're going to say this, like dissolves like. And I kind of addressed this on a couple of the previous slides, but let's get it in your notes, right? Polar dissolves polar, right? So water can dissolve things that are charged. Nonpolar dissolves nonpolar, right? Things that are nonpolar can dissolve things that are nonpolar. All right, so they don't really, the two things don't mix. It's kind of why like water and oil don't mix. Water is polar, right? Oil, which is a fat, is nonpolar. So they don't mix very well. Another thing that affects solubility is temperature, right? So there's different rules for different types of solutions. However, in general, the higher the temperature, the more stuff you can dissolve, right? Okay, and the easier things dissolve. And last is this, pressure, right? And pressure applies specifically to gas-liquid solutions. And we'll be addressing that as we come to that portion of this unit. Well, last but not least, let's talk about this, expressing concentration, right? So we've got this idea here, something that we talked about in Gen Chem, right? Molarity, okay? So moles of a solute per liters of solution. Now, this is one way of expressing concentration. We're going to talk about another way in class that's not as important, but you may come across. Okay, One thing about molarity is this: it can change with temperature, right? So because volumes can change with temperature, right, that affects our liters of solution volume, right? So that could change our molarity if the temperature changes. Well, thanks for tuning in. I hope I gave you a basis for talking about solutions as we get into this new unit. Thanks for tuning in. I'll see you in class on Thursday. Bye-bye.